Hello everyone, welcome to the Mathematics of my channel. In this video, we are going to solve this nice integral. Integral from 0 to infinity arctan of x over x times 1 plus x plus times 1 plus x square. Well, I'm going to begin with substitution. So, in the numerator we have arctan of x. So, let's take arctan of x is equal to theta. Then if we isolate the x, we have x is equal to tan of theta. Then if we differentiate, we have d theta is equal to 1 over 1 plus x square times dx. Okay, then we can plug in. Okay, let's take our integral is equal to I. Then we know I is equal to integral form. Now we should change the boundaries when x approaches to 0. We know theta also approaches to 0. When x approaches to infinity, arctan of infinity, we know pi over 2. So upper boundary pi over 2. Then arctan of x, we have theta. Then x we know tan of theta. So tan of theta 1 plus tan of theta, then 1 plus tan square of theta. Here dx, we know dx is equal to 1 plus x square times d theta. X we know tan of theta, so we have 1 plus tan square of theta d theta. Okay, now we know 1 plus tan square of theta get cancelled, and now I'm going to simplify a little bit. 0 to 5 over 2. Then here we can write theta over tan of theta. 1 plus theta and theta get cancelled. So here theta over 1 plus tan of theta d theta. Now we can see here theta times 1 theta, then theta tan theta. Here also theta tan theta get cancelled, so we will have previous function. Okay, then let's break this integral into two different integrals, and at the same time we know definite integral independent of the variable. So instead of theta we can use x. So we can write this is equal to 0 to 5 over 2. Here x over tan of x dx, then minus integral from 0 to 5 over 2 x over 1 plus tan of x dx. Okay, let's take this integral is equal I1 and this integral is equal to I2. Okay, now we have to evaluate I1 and I2, two integrals. So I1 we have 0 to pi over 2 x over tan of x dx. Okay, let's solve this integral first. So we have 0 to pi over 2 here x. Now 1 over tan of x we know, cotangent of x. So x times cotangent of x dx. Then we know we can solve this integral by parts method. So we have 0 to pi over 2. So we now we should select first function and second function. So we know second function should be integrable. So here x, then d by dx. If we integrate cotangent of x, we know we have natural log of sine of x, and here dx. Now we know product of these two parts. So we have x times natural log of sine of x, limit from 0 to pi over 2, then minus integral from 0 to pi over 2. Now rewrite second function, this one, natural log of sine of x, then derivative of x we know 1, so here only dx. Okay, then if we plug in 5 over 2 upper limit, sine of 5 over 2 1, natural log of 1 we know 0. If we plug in 0 in the beginning, it should be a 0. Okay, then we have 0 times 0 to pi over 2 natural log of sine of x. We solved this integral in a previous video. So we know the answer is minus pi over 2 natural log of 2. So we have pi over 2 times natural log of 2, and we know this is equal to I1. Okay, now I1 pi over 2 natural log of 2. Okay, then we are going to solve second integral I2, this one. So we have 0 to pi over 2, I2 is equal to 0 to pi over 2 x over 1 plus tan of x dx. Okay, how to solve this one? How to begin? Well, first I'm going to convert tan of x by sine and cosine. So we can write here 0 to pi over 2. Tan of x, sine over cosine. So x times cosine of x over, here we have sine of x plus cosine of x dx. Okay, then as a next step, sine plus cos. Well, here 0 to pi over 2. Then we have x, and this cosine of x, I'm going to write sine of x plus cosine of x, then plus cosine of x minus sine of x. Now we know sine of x get cancelled, cosine of x and cosine of x, 2 times cosine of x, so we should divide it by 2, so 1/2. Okay, then here sine of x plus cosine of x, and here we have dx. Well, then we can divide this part by denominator and also this part, so we can break our integral. So here 1/2 integral from 0 to pi over 2, we know this part and this part get cancelled, so we have x dx. Then again here plus, so plus 1/2 integral from 0 to pi over 2. Now here we have x times cosine of x minus sine of x over sine of x plus cosine of x dx. Okay, let's integrate. So here we know 1/2. If we integrate x, we know we have x square over 2, limit from 0 to pi over 2, then 1/2. Now how to evaluate this integral? Okay, again IBP method, integration by parts method. So here 1/2 integral from 0 to pi over 2. I'm going to write x as a first function, then our second function will be integration of this part. So we know natural log of sine of x plus cosine of x, because we know the derivative of the denominator placed in numerator. Okay, then here we have integral from 0 to pi over 2, this part, and here we have again dx. Okay, now here 5 square over 4 times 4, so 5 square over 16, then plus 1 half times product of this function, so x times natural log of sine of x plus cosine of x, limit from 0 to 5 over 2, then we have minus 1 half integral from 0 to pi over 2, then we should rewrite this function, so natural log of sine of x plus cosine of x dx, because we know the derivative of x is equal to 1. Okay, then here 5 square over 16. Now if we plug in pi over 2, we know cosine of pi over 2 0, sine of pi over 2 1, but natural log of 1 is equal to 0. Then if we plug in 0, so we know this part totally 0. So we have 5 square over 16, then minus 1 half integral from 0 to 5 over 2. We have natural log of sine of x plus cosine of x. So here we have sine and cosine, but I have to convert it only sine or cosine. Then our integral will be very easy. Okay, so minus 1 half 0 to 5 over 2 natural log of, then I'm going to multiply by square root of 2. At the same time we should divide it by square root of 2. So here sine of x plus 1 over square root of 2 cosine of x, then here dx. Okay, let's simplify. Now here 5 square over 16 minus 1 half integral from 0 to 5 over 2 natural log of, now here square root of 2 times, now this part we can write okay, sine of 5 over 4 sine of x plus cosine of 5 over 4 cosine of x here dx. Then we can simplify 5 square over 16 minus 1 half 0 to 5 over 2 natural log of the square root of 2 times, now this part we can write by using cosine, so we know this one is equal to cosine of x minus 5 over 4 and here dx. Okay, then we have here 5 square over 16, then here minus 1 half. Now here product, so we can break this one into two integrals, so we have minus 1 half integral from 0 to 5 over 2 natural log of square root of 2 dx minus 1 half integral from 0 to pi over 2 here natural log of cosine of x minus 5 over 4 dx. Okay, simplify. Now here 5 square over 16 minus 1 half natural log of square root of 2 we can write natural log of 2 raised to the 1 half, so 1 over 4 natural log of 2 1 over 4 natural log of 2 here x from 0 to pi over 2, then here cosine of x minus pi over 4, but here pi over 2. Okay, then I'm going to multiply this integral by 2, therefore I'm going to divide upper limit by 2, so here pi over 4, then natural log of cosine of x minus 5 over 4 dx. Okay, then here 5 square over 16. Now here we know pi over 2, so pi over 8 natural log of 2. Then these 2 get cancelled. So here we have minus integral from 0 to 5 over 4 natural log of cosine of x minus 5 over 4. But we know integral from 0 to a f of x dx is equal to integral from 0 to a f of a minus x dx. So instead of x, we can substitute pi over 4 minus x. Then we know pi over 4 get cancelled. Cosine of minus x, we know cosine of minus x is equal to cosine of x. So we have integral from 0 to 5 over 4 natural log of cosine of x, natural log of cosine of x dx. Well, I think now this one familiar with us because I saw so many times, 3 or 4 times, and used various methods to solve this integral. So we know the answer of this integral, g over 2, g we know Catalan's constant, g over 2 minus pi over 4 natural log of 2. So we have 5 square over 16 minus 5 over 8 natural log of 2, here minus g over 2 plus here 5 over 4 natural log of 2. Okay, if we simplify this one, we have 5 square over 16 minus 5 over 8 natural log of 2 plus 5 over 4 natural log of 2, we know, plus 5 over 8 natural log of 2 minus g over 2. Okay, this is the answer for I2. So we know this is I2, and we know I is equal to I1 minus I2, right? Here, yes, I is equal to I1 minus I2, and I1 is equal to pi over 2 natural log of 2. So we have pi over 2 natural log of 2, then minus I2. So we have minus 5 square over 16 minus 5 over 8 natural log of 2 plus g over 2. Okay, let's simplify. So here natural log of 2, here minus 5 over 8 natural log of 2. So we know 3 times pi over 8, 3 times pi over 8 natural log of 2 minus 5 square over 16 plus g over 2, plus g over 2. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.